myself Keval Patel, Assistant Professor from LJIET. So students, this is our seventh lecture of our this example number 1, which is the design of N type of lattice girder or N type of foot over bridge. But you all know that this foot over bridge is also called as through type of foot over bridge, in which in the 1 to 6 lecture we will discuss about the design of cross beam, design of top chord member and design of bottom chord member. In the last lecture, we will discuss about the forces on vertical member. Okay, so there are four members in which we have to find out forces. So for first member, our force is 279.3 kilonewton, and this force is your maximum force because it is already discussed in our last lecture that for second member, which is U1 L1, some of the portion is in the compression and some of the portion is in tension. So our net force is the less than our maximum force. So for second member, our there are two forces. First force is 202.65. This force is also in compression, and our second force, which is the minimum force, is 83.85. Okay, for third member, our third member is U2L2, and for U2L2 there are another two forces. One is maximum force, so the value of maximum force is 132.6 kilonewton, and our minimum force is 39.3 kilonewton, and this both the forces are in compression. Okay, and at last our fourth vertical member, which is U3L3. So the two forces, first one is maximum force, so the value of maximum force is 132.6 kilonewton, which is in compression, and for second forces, which is called as minimum force, so the value of minimum force is 11.55 kilonewton, and this force is in tension. Okay, so students, in the last lecture we will discuss about the forces of the vertical member, and after that it is already discussed that our maximum force is 279.3 kilonewton, which is in compression. So we have to design for the vertical member as per the design of compression member. So how to design for compression member? So you all the students are requested to go to the step number 8, which is the design of top chord member. So it is already discussed that for through type of truss, your top chord member is in compression and your bottom chord member is in tension. Okay, so for compression member we will design, we have to step, our step is PD is equal to AE into MCD, in which we have to find out AE effective area, and as per the area requirement we have to provide more area than the required area, and we will check whether our selected section is pass or not. Okay, so it is your homework in the last lecture that you have to design for vertical member. Now we are moving further to our last members design, which is the design of diagonal member. So whenever you have to design for any component, you have to first of all find out forces on that member. Okay, so first of all our step number 13 is the forces on diagonal member. So let us check. This is our one diagonal member. Say for example, this is U0 junction and this is L1. This is U0, this is L0 and this is L1. So your first diagonal member is U0 L1, in which this is your first vertical member, which is U0 L0. So you all know that there is an angle, horizontal angle, which is the theta. So what is the value of theta? So you all know that as per our step number 1, which is the geometry of the truss girder, or it is also called as the configuration of truss. that our panel length is 3 meter as well as our height of vertical member is also 3 meter. Okay, so whenever your height of truss is 3 meter and the panel length is 3 meter, then your angle theta. So with the help of tan theta equation, your theta is equal to 45 degree. Okay, so now in this step, if you have the value of vertical members, then it is definitely you have to value of the diagonal members. So how to find out the forces on diagonal members? So let us start our step number 13. So you can see that in this figure, this is the angle between the bottom chord member and the diagonal member. So it is theta, and the as per discussed earlier that our value of theta is 45 degree. Now this is your vertical member, and the forces of vertical member is discussed in the last lecture. Okay, and you all know that for first member, which is your U0L0, the value of vertical force, the value of the vertical member is maximum, which is equal to 279.3 kilonewton, and rest of other three members like U1L1, U2L2 and U3L3, you have to find out two forces as per the load combinations, which is your maximum force and minimum force. Okay, so total seven forces will be find out in our last lecture. So you can see that if you have the value of vertical member, then you have to find out the inclined member with the help of sine theta equation. So your sine theta is V divided by D. It means sine theta is equal to forces of diagonal member, forces of vertical member divided by forces of diagonal member. Okay. Now this is your step number 13, and in this step you have to find out forces of diagonal members. So you have to made your subject is D. So your forces of diagonal members equation is V into cosec theta. Now if you are putting the value of theta is equal to 45 degree, then the equation of the forces on diagonal member is 1.414 into V, because you all know that cosec 45 is root 2 and the value of root 2 is 1.414. Okay, so students, if you have the value of vertical member, then you have to multiply that value with the 1.414 and it is your value of diagonal member. Okay, so let us start. You can see that there is one table in which these first three columns is your step number 11, which is calculated in our last lecture, and the rest of three columns, it is our today's session's answers. Okay, so you can see that your first vertical member is U0L0, and the value of U0L0 is 279.3 kilonewton. And you all know that for first member you have only one values. So for minimum force you have to return as 0. For second member you have to find out two values. For third member and fourth member you have to find out also another two values. Okay. So now let us start our diagonal members force. So it is U0L1. So for U0L1 your equation is 1.414 into V. It means you have to multiply this value, which is equal to 279.3 with 1.414, and the answer is 395 kilonewton. Now minus sign. So you all know that minus sign indicates the tension, and it is already discussed that if your vertical member is subjected to compression force and at the similar time your diagonal member is subjected to tensile force. Okay, so all the calculations is remain same, as you have to multiply the forces of vertical member with the 1.414 and you will get your answer of the diagonal members. Okay, Now, what is the maximum force? So your maximum force is 395 kilonewton, and this 395 kilonewton is your tensile force. It means you have to design for diagonal member as per tension member, which is your step number 10, in which you have to find out three values, and you can see that this is your design of bottom chord member. So this is the revision of the design of bottom chord member, in which you have to find out three values. First one is strength governed due to cross section, in which you have to use this equation. This equation is given on page number 32 of IS 800 2007. So the equation is TDG is equal to AGFY by gamma M0, in which first of all you have to find out AG. AG means cross area, and you have to put maximum force, which is 395 into 10 raised to 3, and you have to check what is the minimum area required for your IS angle. Okay, so after calculating your minimum area required, then you have to provide it the value, then the required value. Okay, so after providing some trial and section error, then you have to another three checks, like design strength due to cross section, rupture and block shear, and all these three values is having the maximum capacity of 395 kilonewton. Okay, if any one answer is less than 395 kilonewton in this case, then you have to revise the section. Okay, so students, this is the revision of your design of tension member. So all the steps are remain same. Okay, so this is your today's homework. Okay, so students, this is the end of today's session. Thank you.